What if, in a wild twist of events, we decided to nuke the Earth's core? Sounds crazy, right? But let's dive into the physics and astrophysics of this hypothetical scenario. Picture our home, the Earth, as a giant spinning marble. At its heart lies the core, a region divided into two parts. The outer core, a sea of molten iron and nickel, and the inner core, a solid ball of the same metals. The outer core, with temperatures ranging from 4,000 to 9,000 degrees Fahrenheit, generates our planet's magnetic field. The inner core, despite being hotter at around 9,000 to 13,000 degrees Fahrenheit, remains solid due to the immense pressure exerted on it. Now, let's shift gears and delve into the realm of nuclear weapons. The energy output of these destructive devices is measured in kilotons or megatons of TNT. For reference, a single kiloton equals around 4.184 times 10 to the 12th joules of energy. The largest nuclear explosion ever recorded, the Tsar Bomba detonated by the Soviet Union in 1961, had a yield of approximately 50 megatons of TNT. That's an energy equivalent of 2.1 times 10 to the 15th joules. So imagine, if you will, harnessing such power and directing it towards the Earth's core. The core, with its extreme temperatures and pressures, already exists in a state of precarious balance. The introduction of a force as potent as a nuclear weapon could potentially disrupt this balance. But how would this energy compare to the Earth's core? The total energy of the Earth's core is estimated to be about 2.67 times 10 to the 31st joules, a number so large that it's almost impossible to wrap your mind around it. The energy from the Tsar Bomba is like a drop in the ocean compared to the energy contained within the Earth's core. So with those numbers in mind, what would happen if we unleashed a nuclear bomb at the heart of our planet? A nuclear weapon like the Tsar Bomba releases about 240 petajoules of energy. That's a 24 followed by 15 zeros in joules. But how does this stack up against the energy stored in the Earth's core? Well, let's find out. Imagine the entire Earth as an apple. Now, the core in comparison is like the seed of that apple. Despite its small size, it's packed with an unimaginable amount of energy. We're talking about a whopping 31,500,000,000,000 petajoules. That's a 31.5 followed by 15 zeros, then another 12 zeros. Quite a mouthful, isn't it? Now let's talk about nuclear bombs. These devices unleash their destructive force through a process known as nuclear fission. In simple terms, fission is the splitting of an atom's nucleus into two smaller nuclei along with a tremendous release of energy. This is what powers our Tsar Bomba. On the other hand, the Sun, our very own star, operates on a different principle. It uses nuclear fusion, where two or more atomic nuclei come together or fuse to form a single, heavier nucleus. This process also results in a massive energy release, and it's what keeps the Sun burning and life on Earth possible. But here's the catch. The energy in the Earth's core, unlike that in a nuclear bomb or the Sun, isn't easily accessible. It's trapped, encased in layers upon layers of rock and metal. So, even if we could somehow deliver a Tsar Bomba to the core, it wouldn't just unleash its energy freely. It would need to overcome the immense pressure and heat present there. In essence, we're comparing apples and oranges here. The energy of a nuclear bomb, while incredibly destructive on our human scale, is just a drop in the ocean compared to the energy contained in the Earth's core. So we have the bomb's energy and the core's energy. Now, let's see how they'd interact. Imagine the moment of detonation. A burst of energy equivalent to 50 million tons of TNT infiltrates the Earth's core. At the heart of our planet, a seething, roiling mass of molten iron and nickel is suddenly bombarded by this tremendous force. The core, normally a sanctuary of immense pressure and temperature, is disrupted. This intrusion of energy sends shock waves reverberating through the Earth's layers. Let's discuss these seismic waves. Picture them as ripples spreading out from a stone thrown into a pond. Except these ripples are powerful enough to cause massive earthquakes, unlike anything we've experienced. It's not just a question of magnitude 7 or 8 on the Richter scale. We're talking about seismic events that could potentially reach double-digit magnitudes. But the shock waves are just the beginning. The Earth's magnetic field, our invisible shield against solar radiation, is tied to the motion within the core. A sudden disruption could cause fluctuations, even a complete reversal of the magnetic poles. We've seen this happen naturally over geological timescales, but an abrupt change could have unknown, potentially disastrous consequences. Now let's consider the possibility of core material ejection. The core, under normal conditions, is under pressure equivalent to 3.3 million atmospheres. if a nuclear explosion compromises the integrity of the overlying mantle and crust. We could see a release of core material. It's a scenario straight out of science fiction. Molten iron and nickel spewing out onto the Earth's surface, creating a new hostile landscape. We can't ignore the fact that all these potential outcomes are based on a host of assumptions. The mechanics of nuclear explosions at such depths, the exact nature of the core, and how the Earth's layers would respond. These are all areas where we have more questions than answers. This initial impact would be catastrophic, but what about the long-term effects? In the aftermath of such a blast, the Earth's core wouldn't just go back to business as usual. The long-term consequences would be far-reaching, extending beyond our immediate imagination. Let's start with the Earth's rotation. Currently, our planet spins on its axis once every 24 hours, a rhythm we've come to rely on for our concept of day and night. But if we set off a nuclear explosion in the Earth's core, the sheer force could alter this rotation. The speed could either increase, resulting in shorter days and nights, or decrease, leading to extended periods of daylight and darkness. Now consider the Earth's magnetic field. This invisible shield protects us from harmful solar radiation, and it's generated by the motion of molten iron within the Earth's outer core. A nuclear blast could disrupt this motion, weakening or even collapsing our magnetic shield. This would expose the surface to higher levels of radiation, potentially causing widespread damage to ecosystems and technology. But what about the core itself? At the heart of our planet, temperatures reach upwards of 5,000 degrees Celsius, driven by the decay of radioactive elements. A nuclear explosion could either heat the core further, causing it to expand, or cool it down by using up these elements. In the worst-case scenario, we might even see the core start to solidify. This could slow down or halt the convection currents that drive plate tectonics, leading to a decrease in volcanic and seismic activity. In each of these scenarios, we're talking about changes on a planetary scale. We're talking about shifts in the rhythms and systems that have shaped life on Earth for billions of years. And while we can't predict exactly what would happen, we can say with certainty that the consequences would be profound and lasting. Clearly, nuking the Earth's core would have far-reaching effects. But could we survive it? After such a cataclysmic event, could humanity survive? This isn't a question we ask every day, but it's worth pondering. Our survival would hinge on several factors, each more intricate than the last. First off, let's consider the immediate aftermath. The vast majority of life on the surface would be extinguished almost instantly. Yet, it's possible that a small fraction of humanity could survive in specially designed bunkers. These would need to be deep underground, well-shielded and self-sustaining. The chances? Slim, but not impossible. Now let's fast forward a few centuries. The surface might be somewhat habitable again, but it would be a far cry from the lush green world we know today. The survivors would face a monumental task, rebuilding an entire civilization from the ground up. They would need to adapt to a drastically altered environment, and their success would depend on their ability to harness the limited resources available. And what about longer-term survival? Thousands, perhaps millions of years down the line? Well, that's where things get really speculative. It's possible that life could adapt to the new conditions, evolving in ways we can hardly imagine. But it's equally possible that the Earth might never fully recover. So, while it's a fascinating thought experiment, let's leave the Earth's core alone, shall we? So, to sum up, nuking the Earth's core would be catastrophic. We've traveled through the layers of the Earth, unleashed the power of a nuclear bomb, and witnessed the immediate and long-term effects. We've seen how such an event would challenge humanity's survival. We've explored the numbers, the data, the complex scientific phenomena. It's clear that this is not just an exercise in imagination, but a profound exploration of our world's limits. Next time you're daydreaming about extreme hypotheticals, remember, physics and astrophysics aren't just academic. They're essential to understanding our world and its limits.